Hey there, Chem Squad. In today's video, we're going to look at titrations. Titration is basically just a lab procedure to help us determine the concentration or molarity of either an acid or a base, and it involves using a neutralization reaction. Now, here's the list of things that you'll likely need to have, and on the left, you'll see a diagram of the setup that we want to create. So you need a ring stand apparatus, which is the pole and the base. You need about 1 to 2 burettes, depending on whether you're using a double burette system or a single burette system. And again, burettes could be spelled B-U-R-E-T-S or B-U-R-E-T-T-E-S. It doesn't really matter. But you're going to need something that's about 25 to 50 mils in length. And this burette is usually made of either plastic or glass. Okay, and most of the ones that we have in the chem lab are about 50 mils. You'll need a burette clamp to hold on to the burette, okay, kind of similar to something that you see here. You're also going to need an Erlenmeyer flask, okay, and I suggest that you use something about 125 milliliters to 250 milliliters, depending on how much you're going to titrate. In terms of chemicals, you'll of course need an acid solution, a base solution, and you're going to need some kind of acid-base indicator solution. We usually limit you in terms of 2 indicator solutions that you can use. So it's either phenolphthalein or bromothymol blue. Once you have all of this, you're going to set up your burette similar to what's seen in this diagram. Okay. Now let's talk about some of the solutions. You're going to hear a couple of terms like unknown solution. Unknown solutions basically refers to the unknown concentration or unknown molarity of an acid or a base. So unknown molarity of the acid or base. Okay. Like most of the time you will know what type of acid or base it is. Okay. There is, scenarios where you don't, and we'll get to that when we get there. But for the most part, it's called the unknown because we don't know the molarity. Now, in terms of a standard solution, okay, standard solution is something that we do know the molarity of. So it's the known molarity of a solution. So of the acid or base solution. Now, usually, if we are creating a titration from scratch by using chemicals, the standard solution is usually set at 0.1 molarity. Okay, so 0.1 molarity is the typical concentration. Of your standard. But sometimes, if you're using chemicals that have already been made, okay, and let's say you're using commercial type of chemicals where there's a set concentration, you shouldn't change it to 0.1. Okay, you just use whatever it is. Okay, but if you're just starting from scratch and you're making your own solutions and you have to make up your own standard, normally you'll make it as a 0.1 solution. Okay. The indicator solution is of course either phenolphthalein or bromothymol blue. Okay. Your phenolphthalein is a good base indicator. Okay, so remember, it turns between colorless to pink. Okay, so if you have something in acid, it's usually colorless. If you have something that's more of a base, it will turn pink. And bromothymol blue alternates between yellow for acids and typically blue for base. Okay, so these two you should know by heart in terms of their color changes and what they indicate. Like I said, you might actually have two different methods of setting up your titration. You might use one single barrette or a double barrette. It actually really doesn't matter which one you use. A single barrette, this system is really fast to set up. So fast to set up and clean afterwards. But one of the slight disadvantages is that because you only have a single barrette, you must be careful and accurate. With adding chemicals. Okay, so usually in a single barrette system, you're dropping one chemical into your Erlenmeyer flask. Okay, there's no real making mistakes. Okay, so you have to be very careful and accurate. That's why, for the most part, when I start you on your first titration, I use a double barrette system. Okay, your double barrette system allows you to do two things. Okay, it allows me to put the unknown in one barrette, and it allows me to put a certain amount of standard in a second barrette. Okay, so that we can use, or we have the convenience of using those two chemicals whenever we need it. Whereas in the single barrette, you're only putting one of those two solutions into a single barrette. Okay, so what the double barrette system can sometimes do is this will help correct mistakes more easily in titration more easily. It's actually just more convenient to have two of them there, but most of my students end up using the single barrette only because they typically are very careful. Okay, so when we say it helps to correct mistakes in titration more easily, I'm referring to a situation where you might over titrate. Okay, and again, I'll talk about this in the lab in terms of how to use the double barrette system when we get there. Okay, and we'll also talk about this over titration near the end of the lesson today. The other thing that I want to talk about is how do we drain liquid from our barrettes. Okay, well, if you look at the barrettes themselves, this long piece of glass or plastic has a little nozzle or knob at the bottom. That's called a stopcock. Oops. So a stopcock controls, okay, it controls the amount of liquid leaving the barrette. So it could be either a stream of liquid or fluid, or it could be drop by drop. So the controls are fairly simple because it usually only turns one of two ways. Okay. If the stopcock is perpendicular to the barrette, then it's closed. So if it's perpendicular to the length of the barrette, then it is closed. If parallel to the barrette, it is open. Okay, so in the first diagram, you'll see that the stopcock is perpendicular, okay, creates 90 degrees with the barrette, and here the stopcock and the barrette are both parallel to each other. Okay, so in this situation, you're going to have chemicals flowing through the opening of the barrette, and here it will be stopped. Okay, it's important that you be able to control the stopcock so that you can adjust the amount that you require. Okay, and you have to be very good at it. Okay, because if you don't, sometimes you'll let too much in, and it might cause something called over-titration. And if you're letting it drip too slowly, you might be sitting there for quite a long time, okay, before something happens. Okay. The other thing that I want to go over with you before we get into the whole procedure part is filling the barrette and reading the volume. Okay, so when you fill up a barrette, so let's say that this is a 50 milliliter barrette. Okay, you'll notice that at the very top, it's 0 milliliters. Okay, the final volume is usually measured at the bottom of the barrette. Okay, so when you're filling up the liquid, you're going to fill it up all the way to 0. But the thing is, when you measure, you always measure at the meniscus. Oops. Okay, so if you remember what the meniscus is that curved bottom. So the curved bottom has to touch the reading. Okay, so on this diagram here, the meniscus is above the actual 0 mark. So we put in too much. So what they're trying to show you in this diagram is that's not a big deal. Okay, since your barrette is closed, okay, all you have to do is open up the barrette and allow the extra liquid to drain. And as you're allowing it to drain, you're watching at eye level for the meniscus to reach the 0 mark. So once it reaches the 0 mark, you're going to close the barrette and everything will be good. Okay, so it's actually really easy to do, but you have to be at eye level, because sometimes if you're not, you might be slightly above the meniscus or you might be slightly below the meniscus. If you're slightly below the meniscus, all you have to do is use a pipette and drop in a few drops of liquid until it reaches the 0 mark. So reading and filling up the barrette is something that you should be able to do quite easily. Now let's get into the actual procedure. I found this particular diagram online, and it actually is a good enough diagram for our purposes. So I'll go through each step from 1 to 5 and show you what's going on. There is another half step that I'm going to include that's not shown here, but it is an important part of titration. Okay, you actually don't need to put it in, but it usually makes titrations easier for first-time students. So let's start with image number 1. So step number 1, you're adding, actually before we start that, let's identify what is the unknown and what is the standard. The standard, let's say, is a 0.1 molarity solution of HCl, which is our acid. Okay, and therefore our unknown, we have no idea what the molarity is of the base. Let's say the base is NaOH. Okay, so here you have an acid solution being added to the Erlenmeyer flask. So we'll simply say add solution, we'll say something like add 10 milliliters of standard solution to the Erlenmeyer flask. Your Erlenmeyer flask is where all the action happens. Okay, it is your reaction vessel. Okay. Number 2, you're going to add some kind of acid-base indicator. Now, since your unknown is a base, we're going to add a base indicator. Such as phenolphthalein. To the flask. Okay, it's only a few drops. So 2 to 3 drops. You don't want to put too much in, okay, because it's not necessary. But I also want you to add 10 mils of water. Okay, to this flask. And the water will make it easier for you to make your measurements and readings. Okay, it kind of slows down the process a little bit so you can get a more accurate reading. Number 3. Now, at this point here, if we just go back to the diagram, okay, this substance here is our base. Okay, so we're dropping the unknown into the Erlenmeyer flask. So we want to fill up your burette with unknown base, or with the unknown solution. Okay, so you want to fill it all the way up to the 0 mark, which is at the very top of your burette. Okay. Now, it's important to remember to close your stopcock at this point, because if you're filling stuff into your burette and it's open, it'll just leak through. So stopcock closed. Okay. So in step 4, you're actually going to open the stopcock and you're going to allow the unknown solution to flow drop by drop. This is called the titration process. Okay. You're going to titrate the acid by adding base drop by drop into the flask. Okay. As you do this, as this happens, the contents in the flask will slowly turn more pink. Okay, it turns pink because we added phenolphthalein. If it's a different type of indicator, it will change a different type of color. But it's slowly going to start changing colors. Okay, now you keep adding it until your entire solution stays one color. Okay, so excuse me. Once the entire solution has changed colors, and stays that color for at least 20 seconds, then we have reached what we call the equivalence point. Okay, so at this point you want to stop the addition of base, okay, of your unknown. Okay, so you want to turn the stop clock, make sure it stops. Okay, actually you would have done that a little bit earlier, okay, because you would see that it changed your entire solution colors, so you would stop it. Then you would swirl around your flask a little bit to see if it the color stays for 20 seconds, and if it does, then that's good. Okay, if it disappears, you can add a few more drops of your unknown. Okay, until again it stays that one color. But when it stays at one color, it's reached the equivalence point. Okay, so here, this is technically the equivalence point. You'll notice that it says your solution has been neutralized. Okay, so in this case, whatever acid and base that you have inside the flask should technically be very close to neutralization. Okay, it's not exactly there. Okay, and there's a reason that I'll explain to you guys a little bit later, but for the most part, we call it the equivalence point because this is where we stop. Okay, so at this point here, you want to record your final volume. Okay, and usually the volume that you used in the titration is your final volume minus the initial volume. Okay. So that little formula there is quite handy to have because you'll use it quite a bit, especially if you're doing multiple trials. Okay. So I want to talk a little bit more about this equivalence point, okay, and what happens if you, by accident, added too much unknown. Okay. So if we go back to this solution here, for our purposes, this should be a very light pink. Okay, it should be very, very faint. But if you've added too much, it'll turn into a very dark pink. And in that case, when you've added too much, we say that you've over titrated. Okay. So let's show that in this series of diagrams here. Okay. So this is at the beginning. At the beginning, when it's still clear, it's under titrated. Okay. So either under titrated or not titrated, but as you keep progressing, okay, so this is the middle of your process. You keep adding drop by drop, and you'll notice that there's a pink swirl surrounded by a whole bunch of color solution. Okay, what you're doing here is you're titrating. Okay, and then at the end, it remains a faint pink. Okay, so at this point here, let's say faint pink is good. If this were a dark pink, that means it's over titrated. Okay, you've added too much base. So usually what's going to happen, and this is a check that I'll get you to do, especially if you have a double barrette system. When you get to the end here, and you have either a faint pink or dark pink, okay, what I want you to do is I want you to add 1 drop of acid. Okay, 1 drop of acid should turn this light pink back into colorless. Okay, if that 1 drop of acid turns the pink to colorless, what I'm going to get you to do then is to flip it back around again and add 1 drop of base. Okay, adding just 1 drop of base will cause the colorless solution to turn faint pink again. If you can go back and forth, okay, by adding 1 drop, okay, of acid or base, then you have reached the equivalence point. So if, and usually it's 1 to 2 drops, so if 1 to 2 drops of acid or base can cause a complete color change, back and forth, then you have reached the equivalence point. Where H plus concentrations equal OH negative concentrations. Okay, that's the whole point. You want to make sure that you get as close to the equivalence point as possible, because at that point you'll have acid and base being equal to each other. So they completely neutralize. Okay, so usually from this point on, you're done the actual titration process. Okay, all you have to do now, take your data and use the titration formula to solve. To solve for the unknown molarity. Okay, so remember, your titration formula is MAVA equals MBVB. All right, so hopefully this lesson isn't too confusing. You'll have the opportunity to investigate and perform a titration several times so that you get used to it. In the end, this is one lab procedure that most of our students know how to do even years later, okay, because we focus on it and practice on it so much that you'll be ready for any sort of titration that you might encounter either in university or in post-secondary. Thank you very much. See you guys soon.